These are the notes for Unit 6, Day 1, and Unit 6, we're going to be talking about quadratics. So you know that quadratics, in general, have a standard form that looks like ax squared plus, let me make that a little cleaner, ax squared, there you go, plus bx plus c. That's the standard form of a quadratic function. Let's say y equals, or f of x equals, or something like that. So that's the standard form. And we also know that when we graph this, we get a parabola. Right? Something that either looks like this or looks like that. So we're going to be spending the chapter looking at quadratics and different strategies we can use for solving them. And we did this a little bit for semester 2. Back in Unit 3, we learned how to graph them, and we learned how to do transformations on them. And so we're going to go back to that vertex form and of the quadratic. And remember, if you remember back, the parent function is y equals x squared, and then this was the vertex form of that. And the vertex form had a vertex h comma k, and it had a multiplier a, which is, we'll call it a scale factor, so that a either stretched it or compressed it vertically. And so when we're looking at this, it says use your knowledge of this function to form the graph without using Desmos. So we're going to go back and graph these by hand like we did first semester. So we know that there's a couple things we need. We need a minus here, and we need a plus here in order to have the vertex form. So let's do a quick rewrite here. X minus 1 squared, because the minus is there, plus a negative 4. So we know that our vertex h comma k then, once we've written it in the vertex form, is 1 comma negative 4. And our axis of symmetry goes through that vertex, and the axis of symmetry is vertical, so it's going to be x equals 1. Notice that it really is just the x coordinate of the vertex. And so graphing that, we're going to do the vertex 1 comma 4, excuse me, 1 comma negative 4. So 1 over 1 down 1, 2, 3, 4. So that's the vertex for this, this quadratic. And before we jump into that, let's just talk about the parent function. Right? The parent function has a vertex at 0, 0, and then we go over 1, up 1, over 1, up 3, over 1, up 5. That's that movement table. Over 1, up 1, over 1, up 1, 2, 3, and over 1, up 5. So our parent function, and if you hold that, then you get a little bit nicer looking parabola. That parent function looks like that. I'm going to redraw that. Wasn't really that good. Let me go a little thinner too. There we go. That looks a little better. So our parent function looks something like that. And so really what we're doing is we're taking that whole parent function and we're sliding it right 1 and down 4. So if you notice, then we can recreate that pattern down here. We can go over 1, up 1. Over 1, up 3. 1, 2, 3. And we can even do the over 1, up 5. Over 1, up 1, 2, 3, 4, 5. We have enough of the graph to do that. So that's that movement chart that we used to do where we would go over, and in this case up because of the positive x squared, over 1, up 1, over 1, up 3, over 1, up 5. So from the vertex, we'll go over 1, up 1, over 1, up 3, and you notice those points are lining up left to right. Over 1, up 5 would be right there. So there's our transformed quadratic. Looks something like that. So how are h and k related to the graph? The h and the k form the vertex. H comma k, just like we wrote above. And the line of symmetry then is right down x equals 1. So here's our line of symmetry. In fact, I think I'm going to redraw that line. Make it a straight line and come back and format that line to be dashed. There we go. So there's our line of symmetry. Okay, so in this case, the a value, it didn't really go into the fact that our a value is 1. That's what's out front here. I'll go back and doctor that up a little bit. And that a value is what makes that over, that movement chart over and up. Remember, that's over 1, up 1 times a, over 1, up 3 times a, over 1, up 5 times a. So that's how we got that 1, 3, 5 pattern for the graphing. So that's what we did. That was a review of what we did for semester in Chapter 3. There's another way of graphing quadratics, which is equally as convenient, and that is something that is called we can do this in what we call factored form. So if you notice, we have this quadratic that we've factored. So we've done some sort of star method or something like this. So we have factored the quadratic, and when we factor it, we have a product, right? That's what factors are products that add up to, or multiply up to what we started with. And so when we're going with that factored form, then what we can do is we can find the zeros. That will allow us to solve for the zeros, which are the x-intercepts. I'll call them zeros right now, where they cross the x-axis. So when we take a look at this first one, our x-intercepts are saying let's let x plus 1 equal 0, and that's x equals -1. And let's let x minus 3 equals 0, and that is x equals 3. So those are our x-intercepts. So at -1, it crosses the x-axis, and at 3, the quadratic crosses the x-axis. So we know that quadratics are symmetrical. So this axis of symmetry is going to be exactly in between those points. So let's see, axis of symmetry, I made pink. So it's going to be right in the middle of -1 and 3. Okay, so if we go right in the middle, that makes it right there. So if you notice, this location is 2 away from that point and 2 away from that point. So the axis of symmetry is x equals 1. It's right between those two. We need that axis of symmetry, we need that line of symmetry to be right down the center of the quadratic. So so if we have the if we have the intercepts, then we can just split right down the center of those intercepts. So we know that's our axis of symmetry. And now we need our vertex. And so the way we get our vertex is that we have to find the y-coordinate. And the way we find the y-coordinate is we put our axis of symmetry value back into the function. So our function is y equals x plus 1 times the quantity x minus 3. So x plus 1 times the quantity x minus 3, we're going to put in 1. So we got 1 plus 1 times the quantity 1 minus 3. And so we know the y-coordinate of that vertex is, what would that be? That would be 2 times negative 2, which is negative 4. So the y-coordinate is negative 4, the x-coordinate is 1, so our vertex is 1 comma negative 4. So we know, 1 comma 1, 2, 3, 4, there's our vertex. And at that point, we have 3 points. We can pretty accurately draw, without our movement table, we can pretty accurately draw that quadratic. I'll show you in a second how those points fit into the chart. But that's enough. 3 points is enough to draw a quadratic. So we can go ahead and draw that without the table. But if you notice, if we go over 1 and up 1, over 1 and up 1, we get those points right there. And these next points are over 1, up 3. That's what those intercept points are. So they correlate to the table, but the nice thing is we don't really need the table to use this factored form. Okay, so let's take a look at this one. And if you wanted to pause the video and try this one on your own, you could. But it's got a minus in front of it, so that's going to tell me it's pointing downward. So let's take a look at the intercept. So by inspection, I know I did a little bit of work here to find the intercepts, but I think we can look at each one of these factors and realize that this factor, an x value of 1 makes it 0. So that's one of the intercepts. And in this factor, an x value of negative 2 makes it 0. So notice it's just the opposite of what I'm looking at. So those are the intercepts. X equals 1 and x equals negative 2. Come on. There we go. So those are our intercepts. And so our axis of symmetry is right in the middle of that. And right in the middle of that is right here. And so that is 1.5 and 1.5 away from each of those intercept points. So that is our axis of symmetry. I'm trying to get that to be vertical. It's kind of hard. It's not quite vertical. I'm going to live with that, though. So there's our axis of symmetry, like that dashed, at x equals negative 1/2. And so our vertex then, I have to put negative 1/2 up here. So x minus 1 and x plus 2. So we know it's y equals minus x minus 1, x plus 2. So that is minus negative 1/2 minus 1, and negative 1/2 plus 2. And you might need a calculator to multiply that out. Kind of wish I would have written a little bit smaller now. There we go. Sorry about that. But we have negative, and then I'll need a bracket there. This is, well, I do actually, negative 3/2. Oh, my pen is too thick. There we go. Negative 3/2, and this is positive 3/2. So we have a positive value, it looks like 9 over 4. So our vertex is negative 1/2, comma 9 over 4. 9 over 4 is 2 1/4, right? 4 goes into 9 2 times with 1 left over. So it's negative 1/2 and positive 9/4. So negative 1/2, let's write on that line, say positive 2 1/4. So negative 0.5, positive 2.25. I'll write it as a decimal. And this negative sign out front says we are inverted, we are upside down. So we know that our quadratic looks like this. And so in this scenario, and I'm going to redraw that. I'm not having a good luck drawing quadratics. It's a little bit better. I'm going to move it now. There we go. Okay, so in this situation, making that movement table might be difficult because the vertex is a decimal. So to go over 1, down 1, over 1, down 3 would be problematic. So this is where this is the advantage to using this factored form, is that we don't really need that movement table. Okay, so this last one, you notice there's a 2 out front now, so our scale factor is 2. But you know, we're not really too concerned about that because the way we're getting these points are through factoring and symmetry. So we would need that if we wanted to generate that movement table, the over and up in this case, because it's positive, it'd be over 1 up 2, over 1 up 6, over 1 up 10, right? We're doubling everything. But like I said, if we're using this factored form, we don't really use that table anyway. So that's the nice thing about using this factored form. So looking at the intercepts, we have an intercept at x equals 1 and an intercept at x equals 3. So we're at 1 and 3 for our intercepts. Our axis of symmetry is right in the middle. So that's right here, which is x equals 2. And so that's our axis of symmetry. And our vertex then, we've got to find our y coordinate. So it's, y equals 2x minus 1, x minus 3. That's our function. And I'm going to put in my symmetry value for x. So 2 minus 1, 2 minus 3. So it's 2 times 1 times negative 1. So that is negative 2. So our vertex then is 2 comma negative 2. So 2 comma negative 2, there's my vertex. And then I can go ahead and draw. And as you can see, actually, before I draw the vertex, look at the chart here, right? Over 1 up 2. Over 1 up 2, right? Those are the first points. Then we can go over 1 up 6. We'll be off the chart already. But you can see that those points do correlate to that movement table if we were graphing it in vertex form. So we have something that looks like that. Okay, so it says how are P and Q related to the graph of the equation. So if you go back up to that factored form, they're talking about this P and this Q up here, this P and this Q. So let's just rewrite that down here. It's y equals a x minus p x minus q. And so that would mean that P and Q are the intercepts. So P and Q, put a little tail on that, are the x-intercepts. And it says, how can you find the vertex of the function without graphing the function? We know it's in the middle, just like I mentioned a second ago. Up above, it's in the middle of the intercepts. And that gets us our x coordinate. And then we'll have to find that y coordinate like we did. We'll have to plug that back into the function. Okay, so then we plug x into function for y coordinate. Okay, so looking at the learning targets then, what we're focusing on here is that we've really focused on reviewing the vertex form of the equation. You know, it's a matter of picking what's most convenient. So learning target 1 is the vertex form of the equation. Vertex form. Okay, so it's the y equals a x minus h quantity squared plus k, right? It's that form where your vertex is h comma k. You have to have the plus and minus in there. Your axes of symmetry is x equals h. A is your scale factor. Let me reverse that. Your scale factor is A, and then we use that movement table. We use that, boy, I'm running out of room here. I guess I'll write it out here. We use that movement table of over and either up or down, right, depending upon whether you see that negative sign in front of the x squared, depending upon whether a is negative, basically. Over 1, up 1a, over 1, up 3a, over 1, up 5a. So we reviewed that. That was from semester 1. And then we really hit hard the factored, or the I guess we can call it the intercept form. I kept calling it the factored form, but it's really graphing intercepts, which is y equals, we still have that a, we just don't use the movement table anymore, x minus p, x minus q, and where we have x-intercepts p and q, and our vertex is right in the middle. So think about right in the middle. Mathematically, we can say that's averaging them, p plus q divided by 2. And then our y coordinate is to plug in x into equation. And our axis of symmetry is x equals just that average p plus q over 2. And then I kind of alluded to it at the beginning, kind of working my way backwards to the learning targets, and we still have this general form, a standard form, so to speak. This y equals ax squared plus bx plus c. And its vertex, the x coordinate is opposite b over 2a. I think we did that, I can't remember if that was the beginning of this current semester or the end of the last semester. And then like learning target 2, in fact, I'm just going to copy this. we get y by plugging into the equation above. And our axis of symmetry is just that x statement up there, b over 2a, the opposite of b over 2a for the axis of symmetry. So going over those three forms, you know, it just depends upon what form you're given as far as writing, as far as graphing the quadratic. So you can go ahead and work the check your understanding. The check your understanding is kind of working backwards. They're giving you the graph. Here's the vertex. Okay, so they're asking you to come up with the equation in a couple of different forms. So you can go ahead and work through the check your understanding and check your notes in Blackboard, where you can find the solutions there, and then you can go on to the homework for the section.